On the next page, we're continuing with trig. In the first problem, we're told there's a third quadrant angle whose sine is negative 5/13. So we can draw roughly what this looks like, and it does help to have at least a visual image of what kind of angle we're talking about here. So you have an angle T that is down in the third quadrant like that. But you can see the questions we're asked are things like what's the cosine of the angle, the tangent of the angle, and so forth. So we may want to also do a triangle analysis on this, where we ignore the fact that it's negative, and we just look at what would really amount to the reference triangle. So in this picture, well, let's say this angle, so it's a little more realistic. So if this angle is angle theta, then this triangle that has opposite side 5 and hypotenuse 13 would reflect the sine of theta is 5/13. And then we can use the Pythagorean theorem to determine that this side has length 12. So this reference triangle is a 5, 12, 13 right triangle. So when we ask for the cosine of the angle, we're asking for, in this picture, the adjacent over the hypotenuse, so 12 over 13, but it's a third quadrant angle, so we know that that should be a negative value. When we want to know the tangent of T, that's going to be the same as the tangent of theta in our triangle, as long as we take into account which quadrant we're in. So in my triangle, the tangent of theta is 5/12, and this is a third quadrant angle, so tangent is positive in the third quadrant. For part C and D, it helps to go back to the original unit circle picture. If the angle T is as I've drawn it in this diagram, then adding pi to T will give you an angle up here. So so pi plus T would refer to an angle that's in the first quadrant. And so what's going to happen is, because of symmetry, we should get the same value we got for cosine, but now in the first quadrant, so 12/13 positive. And then finally, the last question asks for sine of T plus 100 pi. Well, of course, 100 pi just means go around the circle 50 times, but you'll end up pointing in the same spot, so you'll have the same value of sine that you had in the first place. So negative 5/13 matches the original value of sine of T.
The key to word problems is being able to draw a picture of the situation that's being described, and we're used to these problems where the picture will end up being a triangle, and we'll either use our knowledge of right triangles or our knowledge of the law of sines and cosines to answer the question. So on this it says that, it says that we're measuring our line of sight up to the top of a mountain. So we have potentially a right triangle here with a 20-degree angle, and this is the height of the mountain that we're trying to find. But we're not given the distance that we're standing from the mountain. Instead, we're told that if we were to back up 1,000 additional feet, then we get a different line of sight angle. So angle of elevation from the second point will be 18 degrees. So we could actually solve this using algebra and right triangles, but if we pull the base picture out, we can see that we actually know these two angles, and we know this side. So that's enough to determine all of the information about the right triangle. Remember, this is 18 degrees, and then this angle here, because the the external angle there is 20 degrees, this angle must be 160 degrees. And then therefore this third angle, remember the three angles have to add up to 180, so the third angle up here is only a 2-degree angle. So we know all three angles in the triangle, and we want to determine the length of one of the other sides. So it doesn't really matter which side I pick. I'll pick this one. It'll be a little bit easier to work with. So I'll find that this side B. I'll do this using the law of the law of sines. What I know, if I give myself a little bit of room over here, is that the sine of 2 degrees divided by the length of its opposite side, which is 1,000 feet, is the same thing as the sine of 18 degrees divided by b. So that is using the fact that 18 degrees is opposite the side of length b and that 2 degrees is opposite the side of length 1,000. So from this I can do the algebra to determine that b is approximately 8,854.5 feet. But this is the length b, which is here in this triangle. That's not actually the side that we want. We want to know what h is. And so if you look at it, h is now the side opposite the 20-degree angle. Going back here, look at this right triangle now. I now know that I have a 20-degree angle, and for this 20-degree angle, the h is the opposite side, and the b, which I just figured out, is the hypotenuse. So I can now do a second step, and I'll just do it down here, where I say the sine of 20 degrees is the opposite side, h, divided by the hypotenuse, 8854.5, and from that I'll be able to determine that h is about 3,028 feet to the nearest foot. So the mountain is 3,028 feet higher than whatever height I'm standing at. For part C, I seem to have given myself no room to write here. So for this part, we just open up a new slide. We're given that T is the second quadrant angle. So on the unit circle, means that T is pointing over here somewhere, and that at the second quadrant angle T, I'm told that the sine of T is equal to 1/5. So that means that the y coordinate here is 1/5. So I could stop here and use a right triangle or the fact that sine squared plus cosine squared equals 1 to figure out what the cosine is there. But I'll just wait to see if I need to know that. So the first thing is that I can find the value of t by computing at least approximation of it, by computing the inverse sine of 1/5. So that's part of the problem. The inverse sine of 1/5, if you use a calculator, and again I'll stay on degree mode because in this problem you can see that some of the questions are asked in degrees, so it'll make the most sense to stick to degree mode. So about 11.5 degrees. But obviously 11.5 degrees is not a second quadrant angle, and the reason is that the inverse sine function can only give you answers in the first and fourth quadrant, so it's not going to be able to give you a second quadrant angle. But we know from symmetry that if the sine of 11.5 is 1/5, then also the sine of 180 degrees minus 11.5 should also be 1/5, more or less, approximately. And 180 minus 11.5 is the second quadrant angle. So T approximately 168.5 degrees will be a value of T whose second quadrant value of T whose sine is 1/5. Now the other questions that are asked here, well, the second one's easy because the second one asks for the sine of T plus 720 degrees. And so this is the kind of problem where we just have to think about what adding 720 degrees does. There are 360 degrees in a circle, so 720 degrees means go around the circle twice. So if you were to take the angle T and add 720 to it, you would be now pointing at exactly the same spot you started with. So the sine of T plus 720 will be 1/5. And you can try it if you want. You can add 720 to 168.5 and see if you don't get approximately 1/5. The other question is a little harder. It says what happens if you add 90 degrees, and that's really not one of the symmetries that we talked about. If you try looking at it on your picture, you can see that it's be about there. If I add 90 degrees to my angle, it means I rotate another 90-degree angle there. And you can see that that point does not have the same x or y coordinate as the original. It is related, but it's not exactly the same coordinate. So if you're not sure, one way to approach these things is just to use your identities. We have these formulas that allow us to break apart a sign of a sum as the sine of t times the cosine of 90 plus the cosine of t times the sine of 90 degrees. And if you remember, the cosine of 90 degrees is 0 and the sine of 90 degrees is 1, and so this ends up just being the cosine of t. So the sine of t plus 90 degrees is the cosine of t. So it turns out I do need to know what this x-coordinate is up here. And I can find this either by using the fact that sine squared plus cosine squared equals 1. That's an easy way to do it without having to draw a picture. I know that sine squared of t plus cosine squared of t equals 1. And from that, remember the sine of t is 1/5, so that's 1/5 squared plus cosine squared of t equal 1. And so that means that the cosine squared of t is 24/25, which means the cosine of t is plus or minus the square root of 24 over the square root of 25, which is 5. So I get an answer that's plus or minus. Which one is it? Well, remember this is a second quadrant angle, and so that we know that in the second quadrant the cosine has to be negative. So I know for a fact that in this case the cosine is negative square root of 24 over 5, and because of this calculation that I did here with using my sum formula, I know that that's the same thing as the sine of t plus 90 degrees. So now back to the page that has the problems on it. D, it asks us to find a function that has a particular period and a particular range. Remember, the period of this kind of function is just 2 pi times the reciprocal of omega, the number that's in here. And that's just the horizontal scaling. When we put the omega t in there instead of t, then we scale the normal period, the 2 pi, by the reciprocal of omega. We want that to equal pi. That's the goal. And so if that's to be true, then omega needs to be 2. It's easy to solve the algebra there to see that that omega being 2 is the only thing that's going to give us the right thing. So we'll have that. We know that we want the range to go from -2 to 8, and so that spans 10 units. From -2 to 8 spans 10 units, and so having the amplitude of 5 will do that. So the A being 5, the A is the amplitude here. If that number is 5, then that means that the scaled function will range from -5 to +5. So the range of this function, if I had g of t equals 5 times cosine of 2t, that has the correct period, has period pi, and it has range -5 to 5. So that range spans 10 units, but it's not the right 10 units. I want my function to be at its lowest -2 and at its highest 8. This function has at its lowest -5 and at its highest 5. So I can make my g of t function have the right range by simply adding 3 to the entire thing. So if the number a is 5 and the number omega is 2 and the number b is 3, then I'll have all 3 things.